So starting with example 5, this third part of the smart notes, it says we're going to use a half angle formula. Those are located on page 387. Hopefully you wrote them down from part 2 of the lecture. And we want to find the sine of 105. Well, what we can do with this, if you're referencing your unit circle, you know that the sine of twice that, 210, is 1 on our unit circle. So we're going to go ahead and use that and cut it in half. So if you're looking at your half angle properties or theorems, then you can see that sine of u halves, that is equal to the radical 1 minus cosine of the angle u divided by 2. So the sine of 210 cut in half is equal to positive or negative 1 minus the cosine of 210. That is now our angle u. It's what u is being cut in half, and that's divided by 2. So we're going to go ahead and plug in these values. The cosine of 210 is a coterminal with or the same as the negative cosine of 30. That's just something to think about. We can certainly take the cosine of 210 from our unit circle, but understanding the negative cosine of 30 is the same as the cosine of 210. And we have a 2. So we have the values positive and negative. 1 plus square root of 3 over 2 all over 2. And simplifying that, we get the square root of 2 plus radical 3 all over 2. The positive square root is chosen because sine theta is positive in quadrant 2. You guys go ahead and try number 47, and we'll come back here and look at your answers. So in order to save some time, we're just going to plug these in. Starting with the sine of 75, we can refer to that as the sine of 150 over 2. And we're going to plug that into the exact same formula that we had before. So it's 1 minus the cosine of 150. Now think of that, the way we did it before, that's the same thing as what in the first quadrant, or the negative value of what in the first quadrant, and that's all over 2. The cosine, we're going to do the same thing for cosine. That's cosine of 150 over 2, and that formula gives us positive or negative 1 plus the cosine of 150 all over 2. And of course, I'm not working these out. That's up to you guys. I'll give you the solutions here in a minute. And the tangent of 150 over 2 is equal to either 1 minus cosine of 150 all over the sine of 150, or it's equal to the sine of 150 all over 1 plus the cosine of 150. So go ahead and work those out, and we'll give you some solutions here in just a minute. So solutions for the first part, for problem number 47, are given right here, so you can stop and check those. We're going to move on to example 6, page 387, and we're going to solve trig identities using multiple angle and product to sum formulas. So our problem is this: 1 plus cosine squared x is equal to 2 cosine squared of x halves. So we can focus on the right hand side first. Squaring what's inside the brackets, we're going to get 2 times 1 plus cosine x all over 2. Those are going to cancel. we end up with 1 plus cosine squared x is equal to 1 plus cosine x. Simplifying this, we rewrite it as a quadratic. Cosine x squared minus cosine x. We're going to subtract 1 with the other one. We get 0. And we're going to go ahead and factor. Cosine x times cosine x minus 1 is equal to 0. Setting both of those equal to 0, we get cosine x equals 0 and cosine x equals 1. We find our solutions from 0 to 2 pi. They would be pi halves, 3 pi over 2, and 0. I'd like you guys to see problem 65. It gives you the sine of x halves plus cosine of simply x. We see that we have one of our half angles. What we're going to do with this, though, is a little tricky, but I want you to see. I think it's fun to watch. We're going to call cosine twice x halves. So we have a similar situation. There's other ways to do this. This is simply one way. We can rename this as cosine of twice x halves. So we end up with sine x halves plus cosine 2 times x halves. And we remember, hopefully, that the double angle, cosine of a double angle, is the same thing as 1 minus 2 sine squared of u. And right now that is x halves. So we're going to bring down the other part, the sine of x halves, plus we just renamed this whole thing as that. We have everything in terms of sine now, and we're going to rewrite this. Let's undistribute that negative and get our 2 sine squared x halves out front. We're multiplying both sides by negative. Minus sine of x halves minus 1 is equal to 0. And I know you're probably hating this problem thoroughly right now, but we have a quadratic equation that we can go ahead and factor. So how do we get 2 sine squared x as our first? We get 2 sine of x halves, and we need factors of negative 1, so that has to be negative 1 and positive 1. So our other factor of our first term is sine of x halves, and our final term is minus 1. And you guys can go ahead and FOIL this out and see that that's what we're working with. So we're going to take this first product, set it equal to 0. We get 2 sine x halves is equal to negative 1. We're going to divide by 2, and we're going to get the sine of x halves is equal to negative 1/2. So we know that the sine is negative 1/2 at 7 pi over 6 and 11 pi over 6. And when we go ahead and solve this, multiplying both sides by, that was handy, multiplying both sides by 2, we get x here. We're multiplying both of these by 2 as well. So we get 7 pi over 3, and we get 11 pi over 3. So that would be 2 solutions for that. On the other side of the equation, let's go back up there, we're going to solve this guy, so we're going to set it equal to 0. So the sine of x halves is equal to 1. And where's the sine equal to 1? We know that occurs at pi halves. So we're going to multiply both sides again by 2, getting rid of that, and we get x is equal to pi. So the only one in the interval 0 to 2 pi is x equals pi. So that would be your only solution. I think this is something that you guys, if you sit and look at it for a while, you can see where things are happening. But this was the tricky part, renaming this as the sine function. In example 7, you can see we're going to rewrite the product as a sum, and we get the cosine of 5x times the sine of 4x. We see a product here. We want to rewrite it as product to sum. This table, page 388, you should have that handy for your notes on test day. And we're working with the sine and the cosine here. So cosine of u times sine of v splits up like this. So we're going to call this our u and this our v. If you look at the top of 388, we can see that is equivalent to 1/2 times the sine of u, which happens to be 5x, plus v, which happens to be our 4x. And that's the difference of the sine, and now it's u minus v, so it would be 5x minus 4x. In simplifying that, we get 1/2 sine of 9x minus 1/2 the sine of x. That would be where we would stop. So we've rewritten from a product, which we had right here, to a sum or difference. That was the objective with that. Let's go ahead and look at example 8. It says using sum to product formulas. This time we want to find the exact value of the cosine of 195 plus the cosine of 105. And we're going to use that sum to product, product to sum on page 388 once again. So we can see that the cosine 195 plus the cosine of 105 is the same thing as 2 times cosine 195 plus 105 all over 2 times the cosine 195 minus 105 all over 2. We're simply going to simplify. This product, sum to product, is found at the bottom of 388. I think I told you the top. These are different. This is at the bottom of 388, and this is a sum to product. We're going to rename it as the multiplication of 2 of our trig functions. So we've replaced cosine plus cosine into 2 cosine, cosine, and now we're just going to simplify this one. We get 2 times the cosine of 150 times the cosine of 45. And simplifying that, we get 2 times negative square root of 3 over 2 times square root of 2 over 2, which simplifies to negative square root of 6 over 2. And then straight into example 9. Find all the solutions. We have sine 5x plus the sine of 3x equals 0, and we want to solve this. It's on the interval from 0 to 2 pi. If I run out of time here, you guys just finish going through this. We're going to break this sum into a product, and we're going to use the bottom of page 388. This becomes 2 sine 5x plus 3x all over 2 times cosine of 5x minus 3x all over 2 equals 0. Go ahead and work on that, and we'll talk about the solution in class.